In addition to its 3+1 and 3+2 milling capabilities, SOLIDWORKS CAM Pro also includes the ability to program a 2-axis lathe with a single spindle and turret. Here you can see a model of a billet motorcycle handle or grip. This model has 3 configurations, and these configurations illustrate the ability to program multiple SOLIDWORKS and CAM configurations using both SOLIDWORKS CAM Pro and CAMWorks Standard. In other words, multiple CNC programs for multiple SOLIDWORKS configurations can be all stored within a single file, and all of the toolpaths are fully associative to the design model and will update automatically. This example also demonstrates where the capabilities of SOLIDWORKS CAM Pro end and where CAMWorks Standard becomes a better fit. If a single turret, single spindle CNC lathe is the machine being programmed, SOLIDWORKS CAM Pro works nicely. Let's take a look. I have my machine selected and my stock defined. So now I'll push the button to extract the machinable features. Now the turning features have been added to my feature tree. I'll generate the operations for machining automatically using the patented technology database. Next, I'll generate the toolpaths for machining. And once the toolpaths have been generated, I can go ahead and simulate the machining process. Now, before we begin the simulation, let's use this pull down to set the simulation to stop at the next setup, and then go ahead and run the simulation. And now you can see that the first operation turns the part complete. And let's go ahead and show the difference between the design model and the machined model. And you can see that everything is in green and has been machined nicely to the design model. If there was any gouging, it would be in red, and we can see the stock on the back of the part in blue that was being used to hold in the chuck for the first operation. What we could do now is turn off the show difference and delete the chip or the slug that is in the back of the part. So let me select it and remove it from the simulation. Now we can go ahead and step through, and now we can see the second operation here. And notice how the chuck is back too far. I need to move that chuck up near the front of the part for that second operation. And then we can watch as the part gets drilled, and then a boring bar comes in and does the finish boring on the ID. Okay, so now let's move that chuck up for the second setup. And remember, these two setups are both on one spindle on the main spindle. So that second setup would actually be like this on that main spindle. So let's open that setup up. And we'll go to the Chuck and Fixture Location tab and click here to define where I want the OD of the chuck to grip on. So I'm going to select that face right there. And then for the Z location, clamping location, I'm going to select up here at the front of the part. And you can see that the chuck moves to that location. And then I can offset it and go back just 1 inch, for example. And that would be a nice place to grip that part for the second operation. So I'm up close to the front of the part there, and I have good stability there. Say OK. And now we can go ahead and run simulation again. And remember, on the first operation, this would be here. The main spindle might be here on the left, and I can go ahead and simulate the turning again. And again, I want to stop at the setup, at the next setup. Okay, and now I can delete the chip again like I did previously. So let me select it and remove it from the simulation. And then go ahead and step through again. And now we can see that the chuck is now being held up closer, and it would actually look like this because this would still be in the main spindle. Usually the chucks are on the left on most lathes. So it would look like this, and then we would go ahead and step through, and it would drill the hole and then use the boring bar to do the finishing of the IDE. And if we compare the design model to the machined model, we can now see that it's been fully machined and it would be good to go. Okay. All right. So now let's take a look at some of the other configurations of this particular part. Let's suppose that we wanted to machine some slots in the outside of this grip for, let's say, rubber inserts so that you could get a better grip while riding the motorcycle. So I'll go to the configuration manager here in SOLIDWORKS and look at this next configuration that includes slots. And you can see now the grip has some slots, and it also has a hole, set screw hole for holding the grip onto the handlebars. And so those features have been added now. And because these slots are just straight slots across the grip, then SOLIDWORKS CAM Pro could program this part thanks to its 3+1 programming capabilities, and it also has 3+2 as well. But in this case, it would be using 3+1 indexing capabilities to mill each of these slots. Okay, and we'll look at what that setup would look like here in a minute. But for now, now that I have changed the SOLIDWORKS configuration, if I go back to the SOLIDWORKS CAM Pro configurations or feature tree, you can see that I get a message saying that there is also a corresponding CAM configuration for this new SOLIDWORKS configuration that includes the slots. So I'm going to say OK here. And now you can see that there are some slots that have been found through automatic feature recognition. And again, the machining operations for the slots and the hole are all included in the SOLIDWORKS CAM feature tree and operations tree. So now I can go ahead and simulate here. And of course, I can generate these automatically just the way we saw for the turning as well. But and notice too, I have a four-axis machine selected. I also have the stock defined from my first operation using an STL WIP file or work in process file. And the machining operations have been generated for the machining of the hole and slots. So let's go ahead and simulate this now. And now we can watch the slots and holes being machined. And you can see it goes around and roughs each of the slots and then finish mills each of the slots, and then it chamfers each of the slots to remove any burrs. Okay. And if we compare the machined model to the design model, again, you can see everything is in green and the part is net to the design model. Okay, so now let's take a look at this same part in assembly mode, and we'll look at how these slots will be set up and machined on a 4-axis mill. So here's the SOLIDWORKS assembly. And now if I go to the SOLIDWORKS CAM feature tree, you can see I have a 4-axis machine selected. And next what I'll do is open the part manager and select the part that I want to machine. Once I have the part selected, I can go to the stock manager. And what I'd like to do is to use an STL file which is a work in process, or WIP file as we call it, of the motorcycle grip after it had been turned using our 2-axis lathe. So let me open that up. And now you can see the stock here is the machined blank from the turning operation. Now I'll go ahead and import the part data from the part that we've already programmed with the slots. So I don't have to reprogram it. I can just import it here from the part file. And you can see that those features have come in. And if I go to the operations tree, all the operations have come in. So now I can just generate the toolpaths for machining. Before I go ahead and run simulation, I might want to open the setup and add the fixture components that might be in close proximity of the spindle. So I'm going to select the chuck and the jaws here. I'm going to add all the instances of the jaws. And I'm also going to select the center over here, which is in close proximity to the spindle. And these are the components that I'm most concerned about hitting. So I think the rest of the components are okay. Don't need to add them all, but let me go ahead and run simulation now. So I'll simulate the toolpath. And now you can see the chuck and jaws and the center there, and then we can go ahead and run the simulation and we'll see the part being machined. This is why we added the chuck and center to the simulation, and this is also the advantage of using, this shows nicely the advantage of using SOLIDWORKS CAM Pro. You can see that a collision occurred due to this holder that is too large and hit one of the jaws there when it was machining one of the slots. So you can see it here, and if I go just a little bit further, you can see where it left an indent there in the jaw. So we had a collision, and notice how SOLIDWORKS CAM Pro showed us that that collision was going to occur. So now what we can do is go back to the SOLIDWORKS CAM operations tree, and let's open up that operation. And we'll change the holder that's being used for that tool. So rather than this larger holder that's being used, let's select a different holder. Let me go to, let's say this holder here, and open it. And you can see where it's smaller in diameter down there and should clear the jaw now. So I'll say OK. And then let's go ahead and run the simulation one more time. And you can see now that that holder cleared and there's the collision did not occur. And then we can compare the machined model to the design model again, and we can see everything is in green. So it's been machined nicely net to the design. And now we could go ahead and post-process the G-code file for the 4-axis mill. So you can see how quickly and easily you can program parts using SOLIDWORKS CAM Pro, and the advantages of using SOLIDWORKS CAM Pro in assembly mode to run simulation and do collision detection. This concludes this presentation. Thank you for watching, and for more information, go to www.camworks.com.